All right, so we're going to start chapter 10 today, and this is going to cover forecasting. So why do we even care about forecasting? What do you guys think? Who cares if you can forecast?
Like predictions?
Yeah, you want to be able to predict. So if you're a company, what does that mean if you can predict? Stay ahead of the curve. Good. I'm going to tease it more out. So what is it? So let's say you're a car manufacturing company and you can forecast. What does that mean? Sales. And then how many pieces and parts are in a car? A lot, right? So do you make all those pieces and parts, or what do you have to do? You have someone else, so you have your suppliers. So you have to make sure that you have enough supplies, and you don't want to have too many supplies, because if you do, what does that mean?
Wasted money.
So why is it wasted money?
The parts aren't used, and you didn't need to buy them at the point.
So parts aren't used, so maybe you have scrap then, you went on to a different model that uses a different part. And then what about, even if you don't have scrap, what does it mean for the parts you do have? You just throw them out in the front yard, or what do you have to do?
You need to have them used in a car to be able to sell.
Well, I mean, so for the parts you bought a whole stack of parts that you're not going to use. You'll get through all those over the next year. What does that mean with all those parts? You just have them in the front yard, or what do you have to do?
Oh yeah, store them.
You have to store them, right? So if you store something, that means inventory. You got to track that. You got to house it somewhere. It's space. So by being able to forecast, you can do, especially like just-in-time GIT is like a big, huge thing. You could be much more economical from a inventory perspective and not having scrap, making sure things don't get old over time. So forecasting is actually like a really big deal. So we'll talk about 3 different models, starting out with the simple exponential smoothing model. And then we'll talk about 2. There's this guy out there, Holt's, pretty sharp with this stuff. And then we're going to do Holt's trend and then Holt's winter exponential smoothing. And then we'll also incorporate Monte Carlo simulation in here, just like we did way back with the orange juice. So we said, here's the item. So we want to get, instead of that one line, there could be variance. So we want to capture all that variance. And we're going to do it at 95%. And if I remember, 95% was something with a standard deviation. How many do you remember? 2. Good. So we're gonna look at that against 95% of our data, or 2 standard deviations. So that'll be what we're doing over the next 3 days in this chapter. And we're also going to create something called a fan chart to visually see that spread at the end. So pretty cool stuff. So as we look at forecasting, it's kind of similar to the supervised learning that we covered in chapters 5, 8, and 9. And right now, when we talk about supervised learning, what's the big, huge key thing on supervised learning? So we have unsupervised versus supervised. And supervised, we did something.
You create a model.
So we're going to create a model first. So we're going to create a model, and then from that model, we're going to now go and predict demand. In this particular case, we have 3 years worth of data that we're going to create a model with, and then from there, we're going to create year 4, months 37 through 48 demand based on that. So we're going to try to predict that out. So as we start looking at this, you have trends, cycles, seasonal things, and everything else we'll look at. The only guarantee in forecasting is that your forecast is going to be wrong. So that's it. That's the only thing you can guarantee. Whatever you forecast is going to be wrong. It's kind of like the weather people, right? Like, oh, today's going to be sunny. It's like, sometimes you're right. But, So especially products, it's like there's all kind of things out there. So we're going to cover the sword forecasting example. I guess the author is like into The Hobbit or whatever. So any Hobbit fans out there, this is all about the swords from the movie The Hobbit. So yeah. So we have 3 years of sword data, and then we'll see that when we're doing this, we have to take time series data taken at regular intervals. So you can't take 1 month and then 4 months and then month 6 and month 12 and then month 13. They all have to be kind of like a uniform interval, like month 1, month 2, month 3, and so on. And again, we're going to be using these whole concept of exponential smoothing for our models here. So let's go in and pull up our data, and let's go do a quick scatter plot here. So let's jump right on. All right, and then we're going to grab this guy here. So what we can do is we can take our data here. So everybody has a spreadsheet. Anybody not have the spreadsheet? Everybody's got that? So let's go grab the cells A1 down to B37. And let's insert a scatter plot. So you can do that either with quick analysis or up here and insert, either way. I'm going to go up into insert, or do scatter plots, and then we could click this one right here. And then now we see our demand. And then let's put in here under demand, we can actually even put stored demand here. And then these axes don't mean much to us down here. So let's update this. We're going to add some axes. So we'll come into the chart elements, and we're going to click the box for axis titles. And then for a horizontal or x-axis, we're going to put demand. And I can't see, so I'm going to click this, and I'm going to put in bold and make it a little bit bigger so you can see it. And then under the y-axis title, I'm sorry, we should have been backwards. The horizontal axis should have been months, and the vertical axis should have been demand. So this is demand here. Make it a bit bigger, and then we're going to put months in here. Okay. And then let's update our Y value axis so that it goes from 100 to 350, and our X value axis so that it goes to 0 to 36. So how do we do that? Anybody remember how to do that? Good, yeah. So we'll do the horizontal first. So we'll double click this guy. And then once you get in here, you have the, actually, there we go. So we have format the chart axes, and then you can go over into the right one with the little pillars, and then click the axis options. And then we're going to do the minimum is 0 and the maximum is 36. And then we're going to go onto the y-axis, and let's go from 100 down to 350. And why would we go down to 100? What does that do for us? Why do we go there? So what happened when we did that? Our data started really expanding out here. And then when we adjust our x-axis, it actually puts a negative component on there, so you'll have to go back and change the -4 out to a 0. There you go. So if we do this, then now we have a chart. Then how are we doing on our stored data here? How are we doing? What do you guys think? Is this a good thing or a bad thing on our stored data? So we start out with month 1 or month 0. We have month 1, and then what's happening here? Stored sales going up or down? Looks like it's going up. So if you're selling swords, you're like Hobbit swords to geeks and weird people doing Renaissance Festival or everything, then you're loving life. You're like, yeah, this is great. We're selling swords here. Okay. So if we look at this. Let's see if I'm coming through. Ooh, I see a bump right here. If I go through, ooh, I see a bump right here. If I go through, I see a bump right here. What might that be? Look at those months. So if we go on this point right here. Ooh, that's month 12. This is month 24, and that's month 36. Anything happens in December?
Christmas.
Christmas, right? So that might be a seasonal demand perhaps we're seeing, but we don't know, but we're going to find out as we get through here. So that's going to be something that we can look at through autocorrelation. And we're going to put it together a corollarogram, hard to say, to look at that, but that's down the road. So questions, thoughts here? All right, so let's move on. So as we look at our simple exponential smoothing, this is going to predict the future forecast from past data with emphasis on recent versus old. So remember this one. This one you might see that coming up. I didn't make it red, but know that you're predicting future forecasts from past data with an emphasis on recent versus older observations. Foot stomp. So we're going to look at two different components on the simple exponential smoothing. We're going to look at level, and we're going to look, so that's going to be essentially our mean, and we're going to look at the error about that. So as we look at this, this model is going to be very simplistic in nature. It's not going to account for any trends, and it's not going to account for any seasonality. But have no fear, we'll get to that as we go along. So assuming that our historical values are of equal importance, what we can do is we can do an average. However common, this isn't going to provide any correction. So again, what we're going to do is instead of doing the average, what we're going to do is we're going to use the month before, and that's going to be the most recent observation. We'll first start out with the average, and then we're going to correct that with the month next to it. So does that make sense to everybody? So if you just did an average, it's going to kind of put it in the center, versus what we want to do is for us to get level. So we'll start off with level 0. This is going to be the average of the first year's demand, months 1 to 12. But then when we look at level 1, we're going to look at level 0. That's the closest observation to that, plus some error. Level 2 is going to be based on level 1. Level 3 is going to be based on level 2. So you always want to take that observation that's closest to it. Again, that's where this comes from right here. We're going to focus on the recent versus older observations. So this SES forecasts 1 month ahead through the entire series, essentially looking at this model. And then if we look at this error and the percentage of this error is going to be a smoothing constant. We're going to call this alpha. So we'll first start off with, if you look at this, this is historically called alpha. If you have 100%, it's all the error. If you have 0, you have no error. So what do you think might be a good starting spot? If you have 0, no error, and 100% all error, what do you guys think? Where could you start between 0 and 1? Like maybe in the middle, like 50? Yeah, let's do that. We'll start in the middle with our alpha. So that seems like a reasonable approximation here, at least to start us out. And then we'll use the solver to optimize that. So the biggest issue with this simple exponential smoothing is that once we get to the demand in the future, it's just going to be one solid line. Very simple in nature. When we start doing the trend, we could start looking at the, we'll start now, it'll look like it's going up with the arrows. And then once we get the seasonality, we're going to start seeing the dips in there as well. All right, so let's go down into slide 6 here. And then we're going to unhide the simple exponential smoothing worksheet. So we'll come in here to time series and let's unhide this guy. Unhide SES. All right, so now we have our data here. And then we have 36 months of data. So in the A2 cell, we're going to put 36 months. And then in C2, we said our alpha, we said 0 was no error, 1 was 100% error. So let's start off with 0.5 here. And then if you look at this, we're going to do like we've been doing. is finding the sum of squared errors and then go look at that standard error. And we'll do that with Solver. So note that we have our data was months 1 through 36, but I added an extra row here, row 0, and this is going to be our initial cell that we use to get level 1. We said we're going to look to the month before, so we kind of have to like prime the pump with a level 0 on this one. So for us to get level 1, that's going to be based on level 0, and for level 0, we're going to take the average of the first year. So in C5, let's take the average of B6 to B17. That's going to give us our level estimate, and everybody should have come up with 163. Okay, everybody's got that? Cool. All right, so then the next thing we want to do then, if we have that as our level, our one-step forecast then is going to be our level from the previous month. So our forecast, one-step forecast, again, one step, it's just the month before. So if this was our level, if our level was 163, then our forecast for month 1 is going to be equal to that level that we had before. So in D6, you're simply going to do a 3D reference that says equals C5. All right. And then what we can do now is for us to get our error in E6, this is going to be our demand, what we had from the customers, minus our forecast. And this is going to give us our forecast error. So in E6, we're going to say equals the demand B6 minus D6. You can scrape the formula, just do it manually. So you should come up with 2. Everybody good so far? Cruising through? Awesomeness. All right. So now what we're going to do in C6 is we're going to now get our level estimate, and our level estimate is going to be based on C5, the level above, plus C2, and look at that C2. What's special about that C2? What happens when we drag this down? C5 will become what? If we go down, C6, C2 will become, look at the dollar.
Oh, D2.
Not D2.
Still C2.
It's because we're going up and down, the letters aren't going to change, right? But the numbers will change, except we did what? We put C2 because we always want to use, and look at what C2 is. C2 is alpha, so we always want to keep that value for each one of these. So we're going to apply the level from the month before times C2, and then that's going to be based on our error. So by doing that, we'll come up with our level estimate. So let's put that in C6. All right. And there we go. So we think our level then is going to be 164. So what we're going to do now is we're going to autofill C6, E6 down through month 36. So we're going to autofill this down to row 41. And that gives us our errors right now. So now we have our demand, and we have our, so notice that the one-step forecast, it's always going to be that month before plus our error times our alpha. So if you look at this, if you take 239 and this is roughly 32, you're going to get what? 271, and that's what that value is right there. So we took the one-step forecast, which is the previous month's estimate, plus the error, and the error is just going to be the demand minus the forecast the month before. That gives us our error, and we multiply that by alpha 0.5, and that gives us our new level estimate. Ryan.
One
So very good. So then the next thing we can do here is in month 37 to month 48. This is, because this is simple, it simply is going to, the demand is going to be, the future demand is going to be the last estimate we have here. So if you look in B42, so we did all this work up here just to get these values of 37 through 48. So if you want, you can even maybe make these cells gray if you want to. Like a light gray. That way you know that these are kind of like special. This is, so that the information before is what we had, and then 37 through 48 is what we're predicting. Since this is very simple, the best we can do here is all we're doing is predicting level. So for B42, you're simply going to say equals C41, and this is going to be pretty boring because it's just going to be a straight line. If we put this in here and drag it down, if we have C41, if we drag it down, C41 is going to become what? The C stays the same, and the 41 is going to stay at 41 because we have the dollar. Because of this, it's very simple, as its name says, and it's flat. Pretty darn boring, okay? So what we want to do now is we want to go in and optimize our alpha, our smoothing level parameter, to have the minimal standard error. So we've been doing this a couple different times. So how do we get our squared error here? So if this is our error, what's our squared error going to be? So it's, yeah, so it's going to be 4, and this is simply going to be what? E6 raised to the 2 power, and then just pull that down. And you're just going to go down to row 41. So if you look at this, this is going to be our sum. This is going to be our squared error. So we take our error and we just square it. And then up in E2, we want to do our sum of squared errors. So what's that going to be? Just the sum of those guys, right? So you can scrape that formula. So it's just going to be F6 through F41. Okay, so we get 15,346.86. And then and we talked about that standard error before. So this is the same formula we've been using before, and that's going to be the square root of our sum of squared errors divided by the points we had. We had 36, and this is going to be divided by the degrees of freedom. So 36 degrees of freedom, and we had one feature in here. We're only taking into account level, so we have E2 sum of squared 36 minus 1 because we're only looking at one value, alpha only. Does that make sense? You guys see that? So sum of squared divided by 35, and we get the 35 from, we had 36 months that we looked at, and then we only have one parameter we're looking at, which was alpha. So go into F2 and copy this formula. Okay, and we get 20.939. So let's write that down. 20.939. So the next thing we want to do then is go optimize this, and we're going to use solver. We're going to use solver. So which one are we going to use? Are we using linear or not linear? Can we use linear?
No linear.
No linear, why not?
We're squaring.
We're squaring, right? So we said only if it's linear can we use linear. Anytime you're using things like logic, or anytime we're doing something with a square, that forces us into evolutionary. So let's go in and set up our solver here. So we'll go into data and go to solver. So we want to minimize our squared error F2. So click in F2 and make sure that's our objective. And we want to minimize this. we're going to click the minimum. And our decision variable is going to be alpha. So that's going to be C2. So you can just simply click C2, the cell right there. And our constraint is going to be such that we want to keep alpha less than 1, less than or equal to 1. So we're going to add a constraint. And we're going to say C2 is less than or equal to 1. And click on OK. So if you double check, you should be setting your objective to F2. We're going to minimize that by changing C2, which is alpha. We want to keep alpha between 0 and 1. So we do the constraint less than or equal to 1. We make sure we have that box check that says make unconstrained variables non-negative. And then we need to go set our solving method to be evolutionary. And then we're going to solve.
We're going to do the max time.
Max time, yeah, this is a pretty easy. 36 values is pretty quick. This should take like maybe. But good point. See that? I love it. Look at you guys. Wouldn't even like if we had this class, you never used solver nothing. Now look at you guys. Are we gonna do the maximum time? What are we gonna do? Look at you guys. You guys are rock stars, data analysts. So I'm putting together a new video for accounting. And I'd love to get, like, if you guys have any quotes on the class, I would love to put, like, your guys' quotes. I'll even put, I could put your names in there or not have your names in there. I want to have, like, quotes from students currently taking 123. So if you guys have, like, any, like, one line, quick, short sentence or whatever you want to contribute, and you'll be in the video, it'll go to business. And I think I'm going to put it out for the whole PIO, so it'll go out to the whole school. So I'll even put Pioneer, like, Pioneer Alex, Pioneer George, Pioneer Brian, whatever. It's like first guys, these guys are pioneers. All right, we click on OK. And our standard squared error improved slightly from 20.93 down to what? So 20.39. So not earth shattering right here. So we went from 20.93 or 94 down to 20.39. Yeah, 20.4. So we'll do that. Yeah, so 20.4 roughly. Okay. So nothing there. But look at our alpha. Our alpha went from 0.5 to what? 0.73. So that definitely moved. So while this didn't move that much, that alpha almost moved, like we almost had like a 25% shift in that guy when you think about it from 0 to 1. So now let's go plot this guy. So let's go plot this, Ryan.
I'm still going.
Oh, yours is still going?
Yeah.
All right, so now that we have our data, let's go plot this data out. Again, we'll see it's going to be pretty darn boring because it only took into account level and nothing else. Like all those trends, as that thing went up and down, it's not taking account. It's just saying, here's the best level we had at the end, and we're just flatlining that out forever and ever and ever. So this is a pretty boring chart. So let's grab A6 to B41. A6 to B41, and then we're going to do that onto a straight line with line scatter, straight line with lines scatter chart. So insert, scatter, and we're doing a scatter with straight lines. Okay, so we have our chart. I'm going to move it over a little bit. Okay, and then the next thing we want to do is we're going to right-click the chart here. We're going to select data. And then we're going to add a series here. And for, don't put a name in there, but for the X values, you're going to put in A42 down to A53, that's going to be our months. Where it says Y, you're going to blow that out, and we're going to put B42 down to B53, and we'll click on OK. And then we'll click on OK. Now if we look at our chart, we have our demand, and we just have that straight line. Let's go fix this up. So it says simple exponential. So chart title, you just put SES forecast. SES forecast. We'll add some axis titles here. It'll be time on the bottom and demand on the y-axis. So we'll put time, or you could put months if you want to. Months might even be more descriptive. I'm going to blow mine up a little bit just so you can see it. Bold it and blow it up. Okay, and then the vertical axis is going to be demand. All right. And then let's come over and change our y-axis down to be 0, or x-axis to be 0 to 48, and our y-axis is going to be a minimum value of 100. So we'll click on these guys and get to our format axis. Minimum is going to be 100. And then our x-axis is going to go 0 to 48 versus 60. If you do that, it's going to make it a -2, so just go back and change that -2 into a 0. There you go. So now we kind of have our plot. We have our trend, and now we actually have our level going forward. And as you can see, that reflects our putting the demand equal to that last value and pulling it down with that $ locked in. So that's all this model can do. So what we want to do now is we want to go in and go validate our slope and our standard error for this regression line. So before we did items really manually, when we started doing the pregnancy case study, and we said, oh, there's this line estimate function in there, but we're not going to use that for now. We said we'll use that down the road. Well, here we are down the road. So we're going to kind of cheat and do the line estimate of here, and this is going to be like really cool. The key thing to know about line est is that function is that it actually computes it and it comes out in an array. So it has the values come out into an array, and this is key because some of your homework is going to be based on this. I want you guys to go out and search for the line estimate and go figure out what all these values are. But for anybody, you know, if you see M, what's M typically in math? Anybody remember? So in a slope, it's like, right, so mx plus b, yeah, right. So m, so that's going to be your slope right there. So if you look at this, this does like our standard errors, our degrees of freedom, and everything else for us. So this is kind of cool. So if we go out into, so let's go back to the time series sheet. So we're going to go back out to time series. And B39. So actually in A39, type in slope. And then A40, we're going to do the slope standard error. And then for us to find the slope, we're just going to copy this formula. And this is going to look at B2 to B37. And then it's going to look at, so that's going to be our values. And then, so that when you do that line estimate formula, it's going to be the values and then the time. So it's going to be the y-axis and then the x-axis values. And you go true and true. And then we're going to look at in this in this array that it comes out with. So this is what the line estimate array looks like. We want to get the slope. That's going to be in row 1, column 1. And that's where that, we're basically taking the index in 1, 1 of this line estimate right here. So that's what this formula is doing for us. So that'll be part of your homework. Probably the hardest aspect of your homework is figuring out this, what all these values are. But if you look online, it's really easy and it'll pop up really quick. So let's type or copy that formula and paste it in there. But actually, let's do this also as well. Let's go into this store demand and let's do a trend line. So we can do chart elements, trend line, and go into trend line options. And then click this box over here that says display the equation on the chart. And then I'm going to move this up a little bit so we can see it. I'm going to make it bold and bigger. So here's our trend line, and this is what the line estimate got. So this is checking. Okay, so here it says 2.5386, that's 2.54, but if you expanded this out, instead of it being a number, it would equal that value as well. So kind of cool stuff there. All right, the next thing we want to do is find the standard error of this. So we're going to use this formula. This time, so if you look in this chart, where's standard error at?
That's the plus 139, right?
I'm sorry?
Plus 139?
Well, right, plus 1. Well, so that's going to be the, well, no, the standard error is going to be 0.34. But where, so if you look at this, like this little chartlet thing right here, where it has like the MN and everything else, do you see standard error up here? So if you look at SE, that's what stands for standard error. And then which, so in this matrix right here that the line estimate produces, which row and column is that in? So row what? So row 2 and what column? Row 1. So if you look at our formula right here, it has our line estimate, and look at this right here. See where it says T1? That's where it's pulling that value. Okay? The only reason I'm harping on this is because I want this to be part of your guys' homework. And then we're going to do our degrees of freedom. If we look over here, our degrees of freedom, what cell is that over there? What row is it? Row 4, column. And then, so it would be column 1 and column 2. Okay? And look what value we're pulling there. See that? So see the, at the end of these guys, you have 1, 1. That corresponds to that slope. And then here you have 2, 1. That's corresponding to the standard error. Over here you have 4, 2, and that's going to correspond to the degrees of freedom. So that's what this is doing. We're using index to pull those guys out of that matrix, out of that array. All right, so let me catch up to you guys. So we're standard error here. All right, and then B41, put degree of freedom. So we're going to put deg of free or something like that. And we said that's going to be 4.2. And then now we have all the values to do our t-test. Does anybody remember what that t-test does for us? What does our t-test do? So that was going to be the goodness as far as the probability of us just pulling this out of the air, the randomness of that. So this is going to tell us how good the probability of this line coming about just based on chance. So it's basically the goodness of the plot. And that's going to be based on the t distribution there, the t-test. And that t-test is taking the absolute value of the slope divided by the standard error of the slope. Is going to make that an absolute. And then it also takes into an argument the degrees of freedom. And this is going to be a two-tailed solution, and that's what that 2 stands for. in doing this, I'm going to put in t-test over here. T-test p-value. So we have a 1 times 10 to the minus 8, so 0.801 chance of this being, by chance. So it's like 1 in what? 1 in 10 million chances. So it's probably, this is a good fit. So we have a 1 in 10 million chance of this coming about by just chance. So this is probably pretty good. The ones we saw before were like 1 times 10 to the minus 29. So it was like way crazy fit. So at the end of the day, if this is essentially 0, so we can say, yeah, this is a legit fit. If the glove fits, a quit. If it's here, it's legit fit. To borrow off OJ, in spirit of OJ being released. All right. Fits, a quit. All right. So the next thing we want to do then is we want to go into the Holt trend exponential smoothing. Our last model only accounted for level, that's it. But what we can do is we can have level, and then now we're going to take into account this whole concept of trend. So we're going to have level from the previous value, we're going to have trend from the previous value, and then we're going to multiply that by alpha for the demand, and then we're going to subtract out the level and the trend. So if you look down here, here's this kind of funky formula right here. And this is going to be taking into account both level as well as trend. So what do you think is going to happen to our model? Is it going to get better or is it going to get worse, do you think, taking into account level and the trends right now? I think better too. Yeah, good. Okay, so this is going to get better for us. So let's go in and unhide the Holt trend corrected sheet. All right, and then up here we're going to put months. We're going to put 36 in A2. And then the trend, so we had alpha, that was what we used for the correcting factor for level. We're going to use the term gamma to be the trend error. So we have alpha and gamma. So we started alpha out between 0 and 1 at 0.5. Guess where we're going to start gamma at? What do you guys think? That value also has to be between 0 and 1. So we started alpha at 0.5. Where do you think we'll start gamma? 0.5. There you guys go. So let's set alpha and gamma to 0.5. And then we're going to add, so on this one, to get the trend, we're actually going to have to plot out the formula and get the trend. So let's grab A6 to B33. So notice this time, how much data did we grab? We did the simple exponential smoothing. What do we start off with? We start off with the average of the first year. This one, we're actually going to take our trend line based on 50% of the data. So before, when we set our initial level, we set that equal to the average of the first year. For this trend, we're going to take half our data and we're going to set our trend line. And then that's going to be we're going to have the level and then the trend line, and then we're going to go from there. So that's why we're grabbing from A2 or A6 down to B23. If you look, you'll see month 18 right there. So let's grab this data and create a scatter plot, and we're going to add a trend line. So you can just do quick analysis here. Come into charts, and let's do a scatter plot. All right, And then actually you can go up and change chart type up here if you want. And let's just do this scatter plot, no lines. Okay. And then I'm going to move this over just so it's not on the other stuff. And then we could do the same thing with the axes. And we could set in time and demand. And we could call this chart trend and level. Trend and level. And then let's go back, let's go in and update our time and our demand. So that time is going from 0 to 18. George.
I have a question with the chart. It's not letting me add it.
It's not letting you add the charts?
Yeah.
So just go up, grab the values and go up to the top and go insert.
Yeah, that's right there.
Okay, let me see. So from here, let's go in and grab our update the months to go 0 to 18, and let's do our trend here, or vertical axis, and make that go from 100 again. All right, there we go. And then from here, what we can do is we can go plot our trend. So we click on the plus and do the trend line, and click on the arrow, and then do more options. And we can do the set equation on the charts. And then we're going to take that equation, and then I'm going to make it bolder and bigger so I can see it. Okay, so then this is going to be what we use for our initial intercept and our initial trend right here. So if we come over, back over to C5, our level is going to be 155.88, 155.88. And then our trend is going to be 0.8639. And that's what we're going to use for our initial value. So we're basically training it with that first year and a half of data. And then now we're going to do our factors and our one-step forecast to accommodate now and best fit to alpha as well as gamma. So this is probably a good stopping point for today. We'll stop here, and then we'll plow forward on Tuesday. Cool. All right, so let me save.